You've seen them, right? Those incredible pictures from space. These gigantic, swirling storms that just look absolutely massive. But you hear them called all sorts of things. A hurricane, a typhoon, a cyclone. It can get kind of confusing. So, what's the real story behind these superstorms?
So let's just get right to it. A hurricane, a typhoon, a cyclone. What is the actual difference between them? Are we talking about totally different types of weather or something else going on? Let's figure it out.
I mean, take a look at these two images. At a glance, they look basically the same, don't they? You've got that classic spiral shape, the enormous size, just the sheer power coming off of them. You'd have a really tough time telling them apart just by looking. So, are they different, or is this all just a name game?
And that brings us to our first part here, the storm name game. Honestly, you can think of it like a giant global weather puzzle. And we're going to put the pieces together. Okay, so here's the big reveal, the answer to the puzzle. They are all the exact same weather phenomenon. Seriously. A hurricane is a typhoon, which is a cyclone. From a scientific point of view, there is zero difference between them.
All right, so if they're all the same thing, why on earth do we have three different names? Well, that question right there is the key to this whole mystery. The one and only difference, the single thing that separates them, is geography. It's all about where in the world the storm actually forms. So if one spins up in the Atlantic or the Northeast Pacific, we call it a hurricane. If that same kind of storm forms in the Northwest Pacific, it's called a typhoon. And if you're in the South Pacific or the Indian Ocean, well, then you've got a cyclone. Same storm, just a different neighborhood. So to cut through all the confusion, scientists just use one umbrella term for all of them, a tropical cyclone. That's the official scientific name. Anytime you have a rotating, organized storm system that gets its start over those warm tropical waters, that's what it is. It's the catch-all term that keeps everything simple. Okay, so we've cracked the naming code. Now let's get into the really cool part, the science. How does one of these things even form? Well, you can think of it kind of like a recipe with some very, very specific ingredients. To cook up a cyclone, you need 4 essential ingredients. First, you've got to have warm ocean water. Then, you need an area of low pressure. Mix in a ton of atmospheric moisture. And finally, you need a little something called the Coriolis effect. Let's break down what each of those means. First up, the most important ingredient, the fuel. And that fuel is warm water. The surface of the ocean has to be at least 26.5 degrees Celsius. That's about 80 degrees Fahrenheit. This warm water is basically high-octane gasoline for the storm's engine. Next, you need the starter for that engine, which is a low-pressure area. See, as warm, moist air sitting over the ocean starts to rise, it creates an area with lower air pressure beneath it. Naturally, air from the higher pressure areas all around it wants to rush in to fill that space, and that's what gets the whole thing started. Ingredient number 3 is atmospheric moisture. That rising warm air isn't empty, right? It's loaded with water vapor from the ocean. As that air gets higher and starts to cool down, all that vapor condenses into these huge clouds and rain. And when it does that, it releases an incredible amount of energy, which just pours more fuel on the fire. And now for the final, secret ingredient, the thing that gives the storm its famous spin. It's called the Coriolis effect. It's pretty simple, really. As our planet rotates on its axis, it creates a force that makes moving air curve. And that force is what grabs those winds rushing into the low-pressure area and gets them spiraling. Without the Earth's spin, you wouldn't get that organized cyclone shape. You just have a big, messy rainstorm. So, our cyclone is all cooked up, it's spinning, it's got its fuel, but what's it actually like on the inside of one of these monster storms? Let's take a look under the hood. What's really fascinating is that a cyclone isn't just one big blob of wind and rain. It's got a very clear structure. You have the eye wall, which is this ring of thunderstorms right around the calm's center, or the eye. That's where you'll find the absolute worst of it, the strongest winds, the heaviest rain. But then, as you move farther out, you get to the outer rain bands, where things are a little less intense. The wind and rain come and go in squalls. Now, when we think of these storms, we obviously think of their destructive power, and for good reason. But you know what? That's not the entire story. They also play this surprisingly vital, even creative role for our planet. It's a really wild paradox when you think about it. On one hand, yes, the crazy winds and flooding can be absolutely catastrophic. We've all seen the damage. But on the other hand, all that rain they dump is essential for life. It refills the groundwater that we drink, it fills up the dams and reservoirs we need for farming and generating electricity. They are both an incredible force of destruction and creation. And if you want a real-world example of this, just look at the Philippines. It sits right in what's known as Typhoon Alley. On average, they get hit by about 20 typhoons a year, and nearly half of those make a direct hit. For millions of people there, this double-edged sword of destruction and life-giving rain is just a normal part of the year. So we've seen that these incredible storms, no matter what name you give them, are a crucial part of how our planet works. They're not just random events, they're part of a system. But that leaves us with a really important question. We know their fuel is warm ocean water. So as our oceans keep getting warmer, how is the story of these storms going to change? That's the question we're all going to have to face.